The purpose of this video is to show you how to take equations that have fractions and decimals and make them a little simpler to solve. So first I want to solve this equation, but I want to do it in a way that maybe you would think to do it. So you're thinking you need your x's together on the same side. So add the 3/5 x to both sides. And when you go to add this, you realize you need a common denominator. So we need to turn 1/2 into something that has 10 in the denominator, and then 3/5. And I'm going to move them this way. So the 2 will go into 10 5 times. 5 times 1 is 5. 5 will go into 10 2 times. 2 times 3 is 6. So you would add the 5/10 x plus the 6/10 x and get 11/10 x. Bring down the 8 and the 4. We haven't dealt with them yet. And we want to move the 8 to the other side. 4 minus 8 is -4. And it's time to divide by 11/10. And this is not looking too nice, but it's really not that bad. I tell my students to remember back in the day when they learned how to divide with fractions. Your teacher back then probably said, keep it, change this to multiplication, and flip, which is writing the reciprocal. And simply multiply straight across. So your final answer is -40/11. So that was doable, but it took a lot of space and it was kind of ugly. So now let's do the same equation and clear the fractions. So we knew that our common denominator over here on this problem was 10. You think sort of like that, where you look at the 2 and the 5 and you're thinking, what will 2 and 5 both go into? And the answer is 10. So you want to multiply the whole problem by 10. So every piece gets multiplied by 10. When you do that, basically, you are getting rid of your fractions, because when I multiply 10 times 1/2, it's the same thing as saying, what's 10 divided by 2? That would be a 5. So 5x. 10 times 8 is 80. 10 times 4, 40. On a problem like this, I will start with the denominator. I could just go 10 times 3/5 is 30/5, and then simplify it. But I usually just say, how many times will 5 go into 10? 2 times. What's 2 times 3? 6. So my answer would be a 6. I've gotten rid of all my fractions now, so I can start solving. So add 6x. Subtract 80. And divide by 11. And look, same answer, just slightly simpler, little less hectic, and you didn't really have to deal with the whole dividing by another fraction and things like that. So it just made it a little simpler. On the next problem, we have decimals. So if I wasn't thinking about trying to get rid of decimals, I would just start solving like normal. I would add 3.2 to both sides. 8 and 2 is 10, 9, 10, 11, 12, 13. And you want to divide 13.0 by the 2.5. So this is a little bit messy. You want to move the decimal over one time, a rule you learned a long time ago. 25 will go into 130 5 times. 5 times 25 is 125. Subtract. Bring down a 0. 25 will go into 52 times. So x equals 5.2. But if you don't want to deal with all those decimals, another approach is to get rid of your decimals. I notice every one of these decimals have one digit after the decimal. So that means I can multiply everything by a 10, and that will move every one of these decimals over one place. So it's the same problem. It's just that now I'm not worried about lining up decimals. It just makes it a little easier. I'm going to divide by 25. We're still going to get the same answer of 5.2. So if you see a problem that where your decimals are all over the place, there's two numbers after this decimal, this has no decimal, there's only one number after the decimal, look at the one that's got the most numbers after the decimal and count 1, 2. That means you need to multiply by something that has 2 zeros. Because if I multiply by 100, it'll move that over. Then I have to remember it's going to change that to a 300. It's going to make that, move it over, a 940. And of course, this became 452. So it's just a way of getting rid of the decimals and just making the problem slightly simpler to deal with.